Hello everyone, thank you for joining this session. I am Emrah Mirtekin. Today I will present a design and development study on human-in-the-loop LLM-based assessment in the LMS environments. The main idea is simple. Large language models can help instructor assess open-ended student response, but they should not make the final assessment decision alone. In the proposed design, the LLM will create a draft score and feedback based on a rubric. Then the instructor will review this output before it's shared with the student. So this study is not about the full automation. It is about careful support for instructors. The study starts with a real problem in assessment. Open-ended questions are valuable. They help us see how students reason, explain ideas, writes, and show deeper thinking. These are things that multiple choice questions may not show very well, but open-ended response take time to grade. When an instructor uses a detailed rubric, each response must be read carefully. The instructor had check different part of answer and give useful feedback. This is hard in large blended or online courses, so we have a problem. Open-ended assessment give rich information about learning, but grading and feedback can take too much time. This is where the design problem begins. LLMs can create scores and feedback quickly. This gives us speed, but in education, speed is not enough. An assessment system must be clear. It must follow the instructor's rubric. It must protect student data, and it must keep the instructor in control of what students receive. So the question is not only can an LLM score student response. The better question is how can we LLM support in the LMS without taking control away from the instructor. This study answers that question by proposing by LTI compatible assessment tool. The tool is designed to work with an LMS. It will receive student response, use rubric created by the instructor, and produce AI supported draft score and feedback, but the output will not be sent directly to the student. It will first go to the instructor. The instructor will be able to review it, change it, approve it, and reject it. Then expected contribution is a design model for careful LLM supported assessment. The model show how LLM support can be placed inside an LMS workflow while keeping an instructor as the final decision maker. The design is based on feedback research. Good feedback helps students understand three things. First, what the expected standard is. Second, how their current work compare with the standard. Third, what they can do next to improve. This is why general AI feedback is not enough. If feedback is going to support learning, it should be connected to clear rubric criteria. In this tool design, the rubric is the anchor. The LLM will create feedback in relation to the rubric. Then the instructor will check whether the feedback is accurate, useful, and appreciated for the student. Recent research gives us a balanced picture. On the positive side, LLMs can support scoring and feedback. Some studies show meaningful agreement between human and AI ratings. Other studies show that AI feedback can be structured and useful, but there are limits. Result can change depending on the task, the rubric, the prompt, and the level of reasoning expected from the student. Rubric matching is especially important. An LLM may produce an answer that sounds good, but it may not follow the intent assessment logic. For the reason, the literature supports a combined approach. AI can help the process, but instructor review is still needed. The tool is planned as an external LTI compatible application. This is important because the goal is not to build a tool for only one LMS. LTI allows an outside learning tool to open from the LMS. It can also receive information such as a user role, course information and tool placement. The Tsuji framework is useful here because it hides much of the technical LTI work behind an API. This allows the development work to focus on the assessment part of the tool. So in the Planet architecture, the LMS will provide the course environment, LTI will provide the connection, the studio will support the tool container, and the assessment modules will handle the rubric, the LLM draft, and the instructor review. The site showed the workflow of the proposed system. The instructor will create the task and rubric, then the student will submit a response through the LMS. The response will be sent external to the LTI. Before anything goes to the LLM service, the privacy layer will mask identifying information. After that, the LLM will create a draft, score, and feedback. The most important steps come next. The instructor will review the draft and edit it if needed, and approve it only when it is ready. Then the approved feedback will share the student with the student. So the workflow is not student response goes to LLM and comes back as a grade. It's a reviewed process. The instructor stays between the AI output and the student. The architecture has four main parts. The first part is the rubric and task creation interface. This is where the instructor will prepare the assessment activity. The second part is the LLM score and feedback service. This part will produce the draft output. The third part is the instructor review inference. This is where the instructor will check the AI output and make the final decision. The fourth part is the privacy tokenization and audit layer. In simple terms, tokenization means using temporary tokens, and audit means keeping record. This layer will support the whole system. It's help protect student data and make the process easier to track. Together, these parts separate the main jobs of the tool: task design, AI support, instructor judgment, and data protection. Because the tool may use an external LLM service, privacy-aware routing should be built into the workflow from beginning. The system should use data minimization. This means sending as little student data as possible. The LLM should receive only what it needs for scoring and feedback. The rubric, the task context, and the student response without identifying information. Student names, emails, IDs, and course identifier should be replaced through tokenization before the request is sent. Here, tokenization means using temporary tokens. The token map should stay inside the institution or tool environment. It should not be sent to LLM provider. The system should also keep an audit log. AI output, instructor edits, approval status, and release history should be logged. This will make the process easier to check later. This inference shows how the human in the loop idea will work in practice. The instructor will be able to see the student response, the rubric criteria, the suggested score, and the AI generated feedback. The instructor will also have clear actions: revise, approve, return the student, or override the score. This matters because review should not be just for show. The instructor should have real control over the assessment result. In this model, AI output is a draft. It can help the instructor but does become final until the instructor approves it. The study follows a design-based research approach. This first step is requirements analysis. This means identifying instructor needs, LLM's connection needs, and limit in the assessment workflow. The second step is architecture design. Here the LTI launch follow tool parts, privacy layer, and review inference are planned. The third step is prototype development. This means build the first working version of the tool. After that, there is a workflow, feasibility review, and the design is improved step by step. The evaluation focus on feasibility, rubric, alignment, workflow fit, and responsible implementation. In simpler words, it asks whether the workflow is usable, whether it fits the rubric, and whether it supports careful use of AI. A larger study across different LLMs platforms will came later. The contribution of the study can be summarized in 4 points. First, it supports interoperability, meaning it can work through LTI. Second, it supports rubric alignment by keeping the rubric at the center of assessment. Third, it protects structure control by making review of and approval part of the workflow. Fourth, it adds a privacy-aware design for using LLM service for more carefully. The key point is at the bottom of the slide. The final scoring decision remains with this structure. That is the main difference between InDesign and fully automated grading system. The main message of the presentation is that we should move from automated grading to accountable assistant. By accountable assistant, I mean careful and controlled support. The proposed tool aims to reduce assessment workload, but not by removing the instructor. It's designed to support the instructor by making LLM feedback reviewable, rubric-based, and privacy-aware. The safeguards are essential: rubric use, tokenization, instructor review, and audit logging. So the value of the tool is not just that it uses an LLM. The value is that the LLM will be placed inside the controlled educational workflow. Thank you for listening. I will be happy to take your question and discuss the design, the LTI connection, the privacy learner or instructor review workflow in more detail.